Hello and welcome back. This is a video about creative uses for low-frequency oscillators, or LFOs, and it's focused on one particular unit, the Xaoc Devices Batumi, because when it comes to dedicated LFO modules in Eurorack, Batumi is kind of in a league of its own. Although Batumi's been around for nearly a decade now, it's still one of the best options for anyone looking to add some powerful and flexible LFO-based modulation to a modular system. You can just use it as 4 very capable independent LFOs, and that's probably what a lot of people end up doing. But if you dig a little deeper into the modes which link all 4 channels and pair it with a mixing and utility module like the Samara II here, you can do all sorts of weird and wonderful stuff with it, from generating more complex wave shapes right through to drum pattern triggers and polyphonic arpeggiation. Xaoc Devices have kindly hooked me up with a Batumi and a Samara II, and I've spent a couple of weeks coming up with some advanced patches to showcase what they can do together. If you own one or both of them, I hope this video gives you some ideas for things to try, and even if you don't own these specific units, quite a few of these techniques can be achieved with other modules. So here's a quick preview of what's coming up. Okay, first up I'm just going to very quickly recap what an LFO actually is, and then I'll run through the key features of Batumi and Samara. If you already own the modules and you're familiar with all this stuff, then do feel free to skip ahead to the patches, I won't be offended. So anyway, LFO stands for low frequency oscillator, and in this context low frequency means below audible range normally. LFOs typically use the same basic waveforms as analog VCOs, like sines and triangles, and they're traditionally used to modulate parameters like pitch for vibrato effects, amplitude for tremolo effects, and filter cutoff for effects. Of course, in modular you can use LFOs to modulate anything you like, and they're a great way of adding movement and variation to patches. Batumi is a quadruple LFO with 3 different wave shapes available simultaneously on each channel. There's a sine, a square, and an assignable shape, which I'll come on to in a minute. There are CV inputs for controlling the frequency and clocking or resetting each channel, and there's a zoom mode for fine adjustments of the faders. You can just press and hold the mode button to enter and exit. Now, talking of the mode button, Batumi has 4 operating modes which you can switch between using the button. In free mode, the LFOs operate independently. In quadrature or quad mode, LFO 1 sets the master frequency, and LFOs 2, 3 and 4 run at the same frequency, but each one is phase shifted 90 degrees compared to the one before. The sliders then adjust the amplitude of those LFOs. Phase mode is similar, in that LFOs 2, 3 and 4 run at the same frequency as LFO 1 again, but this time the amplitudes are fixed and the sliders instead adjust the phases. Finally, in divide mode, LFOs 2, 3 and 4 run at frequencies which are divisions of the frequency of LFO 1. The division is just set by the slider from divide by 2 to divide by 32. There's a couple of other options selected via jumpers on the rear panel. One controls whether the reset or sync input resets the LFO to 0 when it receives a trigger, or syncs the frequency to a clock signal. The other 2 jumpers let you select one of 4 wave shapes for the assignable output. There's rising and falling saws, there's a triangle, or a trapezoid, which is like a kind of squared off triangle. Now, Xaoc Devices actually make a 3 HP expander called Potty, which offers front panel switches for these options, meaning you don't need to remove the module to change them. I bought a third-party 2 HP version of the panel, along with 3 switches and some jumper wires, and made my own. Actually cost me about 15 quid, and I didn't even need to solder anything. Whichever way you do it, I really recommend using the expanders. I think these are pretty important controls to have available. Also, just a quick note on the firmware. You may know there are various other firmwares floating around which expand the functionality of Batumi further, but I'm not going to get into any of those today. For all these patches, I'm just going to be using the current stock firmware. Okay, alongside Batumi in the case here, I've got Samara II, which is what Xaoc Devices call a utility waveform processor. It has 4 channels, each with an input, an attenuator, and an output. There's also an inverting input on each channel, which is summed with the main input. You can mix 2 pairs of these inputs, or you can mix all 4, and there are positive or negative 5-volt offset voltages available on channels 1 and 3. On top of that, there's a signal processor with 2 separate outputs and 5 modes. You can use these to take the maximum and minimum value of all 4 channels, or just the first 2. There's a clamp mode, which restricts the voltage range of inputs 2 and 4 by setting an upper and lower limit using inputs 1 and 3. There's a scan mode, which lets you select one of 3 inputs using a voltage in the other, and there's a dual sample and hold mode. I'll explore some of these modes in a bit more detail in the patches. And speaking of which, let's start making some noises. Okay, so one of the simplest ways to transform a really basic cycling wave like this sine wave here is to mix a couple of unsynced LFOs together to create a much more complex modulation shape. So I've got this first channel sine wave just running through Samara to attenuate it slightly. I'm taking the mix output, which is going to take all four of these outputs through the scope into a filter cutoff CV input, and I've just got a square wave running through that, so we can just hear the effect of the LFO opening and closing this filter. And if we take a second sine wave from channel 2 into the second channel of Samara and fade this in, you can see we're starting to superimpose this faster sine shape on top of the slower one, and we get this kind of more complex wave. Still feels fairly periodic, but it's got a bit more wiggle in it. We can get this even more complicated by frequency modulating the first channel. So let's take a sine from the third channel here. Let's go to channel 3 of Samara, but rather than mixing it with the output, let's take the output, which will break it, take it out of the mix, put that into the FM input of the first channel, and bring this up slightly. If I take down that faster LFO again, just so we're listening to just LFO1 now, or just the effect of LFO1, and now if I add a bit of frequency modulation to it by increasing this attenuator, so this is getting faster and slower, controlled by this sine wave. Let's bring a little bit of that channel 2 back in. But you can also mix LFOs in a way where they're not so random and they're a bit more cyclical by using divide mode. This gives you LFOs 2, 3 and 4, which operate at clock divisions of the frequency set by LFO1. So I've got a fairly fast sine wave here. I'm controlling a bandpass filter now. And if I take second output, I'm on a divide 4. Let's take the rising saw into channel 2. Bring that sine down slightly. You can see now we've got, for every single rise of the saw shape, we're getting 4 bumps of the sine wave, which gives us this kind of wobbling wave, but which repeats exactly each time because they're synchronized. We could take a divide by 2 sine as well into channel 3, say. And just by playing with these proportions, we can get this wave, which still repeats, but is a lot more complex than a basic sine. So by playing with these divisions and different shapes, you can get these nice rhythmic figures. If you get a square in, there's where you get this kind of stepped effect. So just from mixing these 3 synced LFOs together, we're getting a nice complex sound, which is a mile away from any of these on their own. So here's a nice simple patch using a sequence from the Moskwa driving a voice from Sophia, and I've got a couple of free-running sine LFOs from Batumi to control a couple of parameters on Sophia. One's being slightly attenuated to control the warp, the other one's going straight into ratio and attenuated within Sophia. Now this LFO that's affecting ratio is basically acting a bit like a filter. Because that LFO is free running, it means each note when it hits will be at a different point on that LFO's cycle. So we can take a copy of the gate output, and if we have it in reset mode rather than sync, we can basically reset that LFO with every new note so that we get a kind of slightly more predictable pattern, if that's what we want. Another nice thing to do is modulate the frequency of that main LFO using the pitch CV from the sequence. So I've got another copy of that. Let's run that through the first channel of Samara and into the FM input. So now the LFO runs faster on the high notes and slows down on the low notes. You can control the depth of that modulation with this knob on Samara. You could also reverse that behavior so that the low notes go faster and the high notes go a bit longer. Let's just take it into the inverted input, add a bit of offset. Now the low notes are wobbling fast and the high notes are wobbling more slowly. So that modulation kind of tracks the pitch, which is quite a nice effect to have. So in this patch I'm using the sample and hold mode in Samara with two different LFOs from Batumi to create a kind of arpeggiator. I've got the first channel of Batumi outputting a descending saw, which is going to the first channel of Samara, and then I'm using the second channel of Batumi running a bit faster, taking the square wave output as a clock. I'm multing that to the envelope generator, which is controlling the VCA, which is letting Sophia through, which is the sound you're hearing, and another copy of that clock is going into the sample and hold trigger input on Samara. So it's going to regularly sample that descending saw wave. I'm running the output through a quantizer and then into the volt per octave. So very simple. But if I adjust this attenuator on the first channel of Samara, I can increase the range of that arpeggio. And if I adjust the rate of the saw as well, these are both in free mode, so they're not synced. It means you can kind of dial in some happy accidents where you get a nice pattern that almost repeats. I'm quantizing to a Japanese scale in Ornament Crime. Slow that down slightly. Let's take another copy of that sample and hold output signal just into the ratio input of Sophia, just to brighten up the higher notes a bit, make it a bit more dynamic. So by picking a nice scale, playing around with these, range, the rate of that descending saw, you can either get lots of notes in the pattern. Okay, so in this patch I'm using the divide mode in Batumi to trigger some drums. I'm just using the square outputs as drum triggers. In channel 1 I'm basically firing 16th notes through the transient module G1P, which is like half a mutable instruments branches that's basically randomly switching between a closed and open hi-hat, mostly closed with a few random opens. Channel 2 is on a divide by 4 with this slider, so it's for every 4 fires of that first channel it's going to fire a kick drum. And channel 3 is on a divide by 8, firing the snare drum. And things get quite fun if we take this fourth channel and use it to modulate the division of that snare drum channel. So let's take the output of there, I'm going to run it through Samara for a bit of voltage control. I'm just going to attenuate it basically and add a 5-volt offset to it, and let's just bring that into the division CV input for that channel 3. And now as I bring up this attenuator, channel 4 is on a divide by 16, so basically over the course of a bar it's going to switch between a couple of different divisions of that snare, which gives us this kind of interesting snare pattern, like so. And remember, we've got some other outputs available on all these channels, so let's take the snare output, let's take the triangle from the assignable output of that into the filter modulation on a Platt's voice. So now that modulation is also changing along with that snare pattern, it's getting more frequent. And just take it even further, let's take this fourth channel that's controlling that switching between the two different rates of LFO there. Let's just mult this. Take another copy of it through the second channel of Samara. And let's take that into the volt per octave on that bass note. So now we're toggling between two different pitches, and on the high pitches we're modulating that frequency division, reducing it effectively so we get this kind of faster rhythm. So the basic signal processing function in Samara when none of the LEDs are selected is this minimum maximum. And this lets us do some interesting stuff by basically rectifying the, half-wave rectifying the outputs of the Batumi LFOs. So at the moment I've got Batumi in quadrature mode with channels 2, 3 and 4 turned right down. I've got all the 4 LFOs from Batumi going into Samara. I'm using the descending saw. And we're just listening to channel 1 basically. But because we're taking the maximum output, we're only getting the positive portion of it, because when it goes below 0, the maximum voltage is 0, because the other channels are at 0 volts, so we're not getting the negative voltage proportion. I'm connecting this output, this maximum output of Samara into a VCA, which is opening, I've got a saw wave going through a filter. So we're getting this kind of decay envelope, essentially, with an instant attack and a decay like that. And if I bring up these other faders, this is the quadrature mode in Batumi, so these are all 90 degrees out of phase with each other. Let's bring up the middle one. And as I bring this up, you now get this kind of double envelope. If I bring up these in combination, we can get this kind of dynamic rhythm pattern. Up to kind of 4 semiquavers, but we can make them adjust the amplitude slightly. And now let's take that square wave output from the first channel to clock a Turing machine. So we're just getting some different notes. And we can take the sine wave out of that first channel and modulate the filter. And now we're getting this phrase, which is all in the filter modulation is happening in time. And by playing with these sliders, or we could just play with the knobs on Samara, either way works. You can build up these little rhythmic phrases. So by using the maximum output and ignoring the negative portion of these LFOs, we're effectively getting this envelope-esque shape for building little rhythms. This is probably one of my favourite patches using Batumi. I'm using it in divide mode to be a kind of 3-channel arpeggiator using a paraphonic voice. So I'm using Odessa, also from Xaoc Devices, as the main voice here. It's in its 3-voice paraphonic mode, so I can feed 3 different pitch sequences to it. At the moment it's getting the same one on all 3 voices. I'm using Batumi in divide mode. Channel 1 is the master clock, so the square wave output there is triggering my quantizer and my envelope, which is playing each note basically, opening the VCA, which is just taking the stereo output from Odessa. And then channels 2, 3 and 4 of Batumi are on a divide by 8 at the moment. They're all feeding rising saw waves. You can see one of them on the scope there. They're going into the quantizer, which is set to a pentatonic minor scale, which means every time a clock comes out of channel 1, it's sampling and holding that saw wave voltage, which is giving us this kind of rising arpeggio figure. So far, fairly straightforward. You've probably come across sampling and holding an LFO to create a sequence. But when you've got 3 of them like this, and they're all clock divided from the main clock, you can start doing some fun stuff by adjusting the attenuation. Of one of the voices, or more than one of the voices. So now we get these kind of rising chords. Speed it up slightly. I should say also, just because the outputs of this of Batumi are bipolar, I'm getting them unipolar so that they'll be accepted by Odessa, and also I've got one of them in crime in 0 to 10 volt mode. To do that, I'm actually taking a -5 volt offset from the first channel of Samara, multing that to the inverted input of channels 2, 3 and 4, which is basically inverting -5 volts, so giving me +5 volts on those channels. So that's bringing it into a 0 to 10 range, but attenuated with these knobs. So now we've got these nice rising arpeggio figures, which we can sort of turn into chords. Get gets even more fun when you start playing with the clock divisions in Batumi. So let's take one of these down a bit slower. So that's taking twice as long to rise. Let's speed another one up. So now we're getting this kind of polyrhythmic, polymetric kind of effect. So I want to return to the concept of kind of mangling these LFOs with signal processing using Samara. So I'm going to look at the clamp mode, which basically lets you set an upper and lower limit for the voltage being passed through one of the other channels. So channels 1 and 3 set the maximum minimum voltage, and channels 2 and 4 can pass the signal through, which come out to these A and B outputs. So I've got a fairly fast sine wave LFO coming in on channel 2, and channels 1 and 3 are going to control how much of that goes through. I'm passing it through the scope and into the harmonic level CV input on the harmonic shift oscillator from New Systems Instruments, kind of a filter style effect, opening and closing. So if I turn that up, none of that LFO is really being fed through, but if I turn up this maximum control, that lets through voltages up to 5 volts now, so that's the upper portion of that LFO, a rectified version basically. And if I increase the negative voltage, it's gradually let through the entire LFO. So with both those maxed, it's letting through signals in the range -5 to +5, which is the whole thing. But by adjusting these, you can kind of attenuate, rectify, offset, kind of generally play around with how much of that waveform is kind of clamped between this upper and lower levels. And as usual, this is always more fun if we modulate it with something else rather than turning it by hand. So let's take these offsets off, and let's take another slower LFO from Batumi. Let's take the sine wave to start with. Let's go into the first channel. So you can see it's kind of letting through bits of that LFO in its positive and negative bits of its cycle. Let's take a copy of the same one via the stackable into the other limit. And because I'm going into the inverted input, so it's basically going to be 2 inverted sine waves that are kind of opening and closing above and below the line, and you get this shape that basically follows that master sine wave from channel 1. And you can play with the other wave shapes. Let's go to the saw, and you get some quite nice effects if we maybe take out this, put the offset back in on that. You get these waves that are kind of clamped to one side or other of the wave that's kind of controlling their shapes. This clamp mode is also really great at audio rate waveforms as well, if you really want to mangle a wave by using another waveform to clamp it. So here I've actually got Batumi patched as an audio oscillator. I've got the frequency right up, and I'm feeding in a pitch sequence from the Turing machine, which I'm mixing with a bit of offset voltage from Samara off on channel 1 just to bring this up, give it another couple of volts, or push this frequency up even higher. I'm just taking the sine wave output at the moment, and it's just going through the Optimix LPG, which I'm pinging with the pulse output from the Turing machine. That's the sine, which obviously sounds fairly muted. Let's just flick into that's the trapezoid I've got selected there. That's a saw and triangle on the other saw. Let's keep it in trapezoid. Now, I'm in phase mode on Batumi, which also means that I've got copies of this main oscillator effectively here on these other 3 channels, but I can modulate the phase of these. So why don't we try taking a copy of that pitch sequence into Sophia, which I've got here. I'll take the output of Sophia, not do anything particular, just a kind of sine wavy sound. I'm going to use that to modulate the phase at audio rates on Batumi, which will give us this kind of audio rate phase modulation, which is very similar to FM. Let's take the output of channel 2 from the trapezoid. Let's go into the phase modulation input there, and I'm just routing it through the another channel on Samara. As I bring up this attenuator, we get this kind of wobbling metallic effect of that phase modulation. Let's sweep the frequency on Sophia. up slightly. Let's try the square output. It's great for these slightly metallic kind of clanging sounds. That's with no modulation. And that's with the phase modulation. Of course, you've got 3 channels here to play with as well. You could get some pretty freaky stuff if you started phase modulating them all differently and mixing them together, but this is just a little something to whet your appetite. So I'm back to some drum triggers, and in this patch I want to look at using the phase mode in Batumi to create some kind of weird shuffling drum patterns by taking the notes off the grid a bit. I've got basically 4 drum sounds patched up to the 4 outputs. In phase mode, at the moment they're all in phase with the first channel. So I've got a kick drum, I've got some kind of low percussion which is a pinged surge filter, I've got a 808 clave, and I've got an 808 maraca on the 4th channel. And basically if I move these phase faders, I can basically kind of create a little pattern within that beat. And you can sort of dial in kind of shuffle of your choosing, which is quite nice. You could use this, you could maybe combine these into a clock, which you could then use to drive another rhythm pattern if you get a kind of dial in a feel that you like. But as always, fun to modulate these things. So let's take, at the moment I'm syncing this all to Pamela's new workout, so the first channel is just synced. I've got a couple of other channels on Pam set up with triangle LFOs, which are kind of synced to that master tempo as well. Let's bring these phases down. Let's take 1 through Samara into the phase CV input of this channel. And that low percussion hit is now kind of moving around within the bar. I've got the same with another triangle LFO here. Let's take that for the clave. And by kind of dialing this attenuation in, they're kind of within, because these LFOs are all synced up Pamela's new workout, they're all kind of in time, as in they repeat every bar. But within that bar we can get this kind of unusual shuffle. Okay, so finally I'm going to look at the scan mode in Samara, which is basically a kind of addressable switch. You can feed 3 different input signals to channels 2, 3 and 4, and then you can use the voltage in channel 1 to switch between them. So at the moment I've got 3 clocked LFOs at slightly different speeds and a couple of different wave shapes fed into these input channels, and I can use the voltage in channel 1. If I put the offset on, that'll just let me manually switch between them effectively as I move through that voltage. I've got the output running through the scope into the filter cutoff in Plat, so let's just have a listen. This is the first one at the moment. So it's kind of sine LFO, just opening and closing the filter. And if I increase this voltage, it'll switch to the middle one, which you can see is this much faster downward saw. And if I keep going, that's another downward saw, but slower again on that 3rd channel. So just by turning this knob here, I can basically select one of these 3 LFOs. But of course I could feed an input signal into channel 1, which would let me automatically control the switching. So as I've got a channel of Batumi left over, why don't I take another slower clock from Pam's to the first channel of Batumi, and then I'm going to take the saw wave into the first input channel, bring up the attenuator. And now as this slow saw moves through, it's going to switch between these 3 in turn. You can see it's kind of rhythmically taking it in turns to route each of these to the filter. And if I take another clock out of Pam's and feed a little melodic sequence from the Turing machine into Plat's, just to give it a bit more of a sequence. Of course, you can play around with different LFO shapes in here, and you can play around with different clock divisions, but it's quite a nice quick way of having a sort of auto-switching rhythmic modulation. So that's about it for now. Hopefully this video has given you a few ideas for things to try, whether or not you've got Batumi in your rack. I think the combo of Batumi and Samara works really well as a modulation hub, and with a bit of creative thinking there are loads of interesting things to do with them. If you've enjoyed the video, please give it a like, leave a comment and subscribe to the channel. I'll be back soon. Thanks for watching and I'll see you next time.